Bueno, pues nada, bienvenidos. Muchísimas gracias por estar aquí. Welcome, Barbara, Álvaro. Thank you very much for joining us today and for share with us your knowledge, experience, expertise, and research. And I think the best person in this case to moderate this session, this talk, is Laura. And the floor is yours, Laura.
Okay,
if you want to introduce them, or if you want to introduce yourself.
Okay. The Barbara Arrowsmith, Álvaro Fernández, they both will present them, and then Miguel Ángel and I, what are persons who are implementing the Arrowsmith program in the SEC institution, will share with you some of our research results and some of our new aims. Barbara, please.
Okay. Well, just a moment, hello, everyone, and just a moment. But really, I think today we have a fantastic opportunity to talk with Barbara and Álvaro about the neuroscience and the application in the education. I think really is a fantastic really opportunity because the focus of the work of the research of this research today is the students, is the learning processes, and really this question is rising about the practice in everyone, and I think I'm sure you are a lot of inquisitive with this person today, and thank you very much. Well, come on.
I guess I'm talking to this, and Álvaro and I love questions. Álvaro speaks Spanish. Sadly, I only speak English. So, but yeah, we love questions. So we want to.
I speak English too.
He does speak English as well. But yeah, so it's an opportunity just to ask questions. I mean, when I started. When I started this work, there was no belief in human neuroplasticity. So I started my work probably in the late 1970s. And at that point, the belief was your brain was fixed, right? And if there was a learning difficulty that was related, well, first at that time, they didn't believe learning difficulties were related to the brain. It was just bad teaching, bad education. So first of all, they said learning really has nothing to do with the brain, if you can believe that. And then they said even if it does have something to do with the brain, your brain is fixed. So there's nothing you can do about it. And I had very, very severe learning difficulties. I was identified in grade 1 a lot of years ago, and that was before there was even the term learning difficulty or learning disability. So I was diagnosed in grade 1 as having a mental block. And because part of my problem was comprehension, I actually thought I had a piece of wood, like a cube, a big block in my head that made learning difficult. And later I learned I had blockages in my brain. I didn't have a piece of wood. But, you know, the belief at that time was, you know, if you have a difficulty, accept it. You have to live within your limitations. So for me, it was like in grade 1, I feel like I was given a life sentence that I was told. My grade 1 teacher told my mother, don't have high expectations for your daughter. She's not going to amount to much. Like her whole life is going to be a struggle. And over the years, I felt there had to be a different way, right? There had to be, I just couldn't accept that I had to constantly struggle. And certainly my schooling was a struggle. And I came across research in 1977 coming out of Russia, a brilliant Russian neuropsychologist, Luria's work, and Álvaro knows of his work. And he was looking at people after World War II with very localized head wounds. So if there's damage to this part of the brain, what can the person no longer do? Therefore, by extrapolation, what is the job of that part of the brain? And as I was reading this man's work, I thought, he's describing my life, right? Like the things that I hadn't been able to do since birth. I knew I didn't have shrapnel in my brain, but clearly for me, parts of my brain weren't doing what they were supposed to be doing. So that was my first aha moment that my problems were related to my brain. And then there was research coming out of Berkeley, again, that you're quite familiar with, Álvaro, was looking at neuroplasticity in rats. And I figured if rats had neuroplasticity, if a rat could actually enhance their brain, they could grow more dendrites, increase neurotransmitters, more glia cells, enlarge capillaries, more blood flowing to the brain. Surely humans must have neuroplasticity. And again, at that time, I was told that's not true. But I thought, I need to try. I need to try to do something. So I created 3 different exercises because I had multiple learning difficulties, and I had no idea if they were going to work. And I worked hours and hours at these. And my life changed, right? It wasn't like, learning a skill. It wasn't learning a strategy. I could now do things as a result of these exercises that I'd never been able to do before. So I figured there is human neuroplasticity. And that's what led to this work, and then the exciting research that we've done over the last couple of years here, looking at, the outcomes not only for students with learning difficulties, but students that don't have learning difficulties. We go to school to learn. We learn with our brain. I fundamentally believe we should put the brain into the education equation and stimulate and enhance cognitive functioning. And we're doing research now looking at the changes in the brains of students as they go through this. And we're seeing increased connectivity in really critical networks. The default mode network, which is related to thinking, kind of that big picture thinking, the executive control network, which is like, executive control is problem solving, strategizing, and the salience network, which is saying, what's critical, what's relevant, what's essential. So my work grew out of, a hunt for a solution to my difficulties and led to this work. So one thing I would encourage anybody here is if somebody says you can't do something, don't listen, right? Like if you believe you can do something, go out and see if you can find a solution, because really that's how science goes forward. It's kind of having that vision and that big picture, and then going out and experimenting and trying. And for a bunch of years, and you can probably talk about this, Álvaro, is, we've been saying we need to build a bridge between neuroscience and education. And currently, I don't think there is much of a bridge, or if there's a bridge, it's pretty rickety and maybe not all that safe to cross. So I'm really excited that, a number of you are maybe going to build that bridge, because we really need to put the brain into education and take what we're learning in neuroscience and directly apply it to education. And that's what I'm really excited about with the work that we're doing here, because it can benefit all learners. And we're, if people are interested, on our website we talk about the research and the different work we do. And it has huge applications from people with addictions, because that rewires the brain in a negative way, people with learning difficulties, students just that want to enhance functions, people with acquired brain injury, and as I'm getting older, people that aren't quite as sharp as you get older, we can enhance that neuroplastic nature of the brain, which we have across our lifespan. So that's kind of what I want to say, and Álvaro, and then I'd love questions.
Un placer estar aquí. So Barbara and I, our stories are very different, but we have also a very similar pattern that I just recognized, which is we love to learn and we love to apply what we learn. So in my case, I've been 20 years working in the US, and I was involved in a few e-learning startups, but I was reading neuroscience books and going to events in Stanford for many years until I came across 2 books. And reading them, and I will tell you which ones, made me realize, wow, this is a huge opportunity and a huge need. What can I do to shape that opportunity? One book is called A User Guide to the Brain by John Ratey. It's a great summary of cognition and the brain and mind. Another one is called The Executive Brain by Elhonon Goldberg, which is about the prefrontal cortex and his own story about how he escaped from the USSR then by using, and he tells the story. And in fact, now, you don't know this, but there's a producer in Barcelona trying to do a movie on his story, and I'm trying to help produce the movie. But the idea was, if neuroplasticity is true, and we live longer lives, there's going to be a massive need to help people enhance their cognitive reserve so that at any point in our lives, we function at the highest level possible. Same as being a physical athlete. Well, we are like mental athletes. We are exposed to very demanding careers and lives, so we have to perform at our highest level. And by building that reserve, we can also delay potential problems. We can delay cognitive problems, dementia. So that's a huge opportunity. And I wrote to Elholm Goldberg after reading the book, and we spoke, what can we do? And we decided to create a company called Sharp Brains, where we track what's going on worldwide. We track new science, we track new technologies, we track new patents, because that way we can see what Apple is working on what Toyota is. So it's very interesting to see patents to predict new trends and applications. And one of the big things we've been doing for years is, in fact, virtual conferences. Before the Zoom era, we were practicing virtual conferences because the science and the industry is global, and we wanted a way to engage people all around the globe. And that's how we met. At some point, you have been helping us a lot. And that's just to explain what we work on. And then Barbara and I, we thought that we can talk about many, many things, but first we want to hear your questions, and because we can approach things more from education, learning disabilities, specific topics, teacher training, the future of schools, lifelong learning, healthcare, neuropsychology. I think some of you are studying that. How the digital revolution is impacting many of these areas. So we can approach things many ways, but we would love to hear some of your questions, and then we can answer them.
Okay, thanks, Álvaro, Barbara, for this first review. Now is the moment to talk with these topics.
Yeah.
Without
Okay,
the microphone, we don't hear.
Yes.
Yes.
Well, we start to work with Barbara in 2017. We went to Toronto. We stayed in the Arrowsmith School in Toronto. And as an international advisory board of the SEC institution, we talked to work together and to use the opportunity that we have with schools to put in practice the Arrowsmith program in our students. And since 2018, we have worked with students of different schools, and the difference with the people with usually attendance to the Arrowsmith program is that we have focused not only in children with learning disabilities, but also in children without learning disabilities, because we thought that maybe the program could improve equally for these other children. And our results show that both children with and without learning disabilities improve their cognitive processes, but in a different way. That was very interesting because those children without learning disabilities improve in less time the same abilities that those children with learning disabilities need more time training, more continuous training and more time, maybe I think that 2 years, 2 academic course, working 2 times per week with Gloria in Sec El Castillo and at least 2 times more at home. But the other children in 3 months and working less time, they increase also their visuospatial memory. And now we are planning to work with, again, with children without learning disabilities. Gloria continues her work with children with learning disabilities. And we will have a control group that is not working with any program because it's interesting to assess how the program in a period of time can improve these cognitive processes. And Now we are trying not only cognitive tasks, but also we will use a task which is more related to academic achievement, because we can obtain results about not only how the processes improve, but also how these processes have an impact in academic achievement. And it's more or less what we are doing now.
I have a question. Oh, go ahead.
I was just going to say, I mean, certainly what you're saying in terms of students with learning difficulties, we've done imaging research to look at the brains of students with learning difficulties compared to students without learning difficulties. And there is a very different pattern. So it makes sense that it takes longer if a student has a learning difficulty. And what we're seeing in the brains of students with learning difficulties is there's a pattern of hyperconnectivity and underconnectivity, which is happening, where they're underconnected areas, so areas with weak connectivity, which means that they aren't processing effectively. And then there are parts of the brain that are hyperconnected. They're working really, really hard, but they aren't designed to do what those underconnected areas are supposed to do. So what you get is a brain that is working really, really hard, but inefficiently, right? It's trying to compensate, but it can't. And if you think about a lot of programs, at least in North America, for students with learning difficulties, they make kids compensate, right? So they're trying to use areas that aren't designed to do what those other areas are doing. So the external is mirroring the internal. So you get these students that are spending incredible energy and effort to try to learn something, but it's inefficient because they're using cognitive functions that aren't designed to do what those weak areas are doing. And that was my experience, certainly going through school, where I would work 20 hours a day, sleep 4 hours a night, 7 days a week, just to try to get through university, because I was trying to use strengths that weren't designed to do that. And to me it was fascinating when we saw this imaging research that the brain is actually mirroring what's happening in the external world. And what we see as students with learning difficulties go through the program is those underconnected areas start to strengthen in connectivity, and the hyperconnected areas start to reduce in the hyperconnectivity. And we're seeing that pattern in the research both with individuals with traumatic brain injury and individuals with learning difficulties. So the brain is starting to normalize in its processing. So it's becoming much more efficient, and those underconnected areas, as they strengthen, are able to do what they're designed to do. So you get a much more efficient brain. And a lot of students sometimes ask, am I going to lose the strengths that I have or the gifts? And what we find is actually allows them to use them more effectively, because they're not having to use those extra resources to shore up and support a weakness. It's kind of like it frees that energy in the brain to do what those areas are designed to do.
Yes, it's very interesting, because even when we did not assess subjectively, but we could have seen that that children with learning disabilities increase their ability to persist in the task, and also to work in an autonomous way, because they at the beginning they ask for you, I need help, I can't understand, I can do it, or I don't try again. But they are working, because I think that one of the most relevant things of the program is that it is a challenge for the students, even when they know about clocks in this case. It's a challenge, and it has different levels of difficulty, and always is a challenge. When you gain a level and you have feedback and you feel, oh, I did it, you have a next level, and it's necessary that a cognitive program or training have these both things. It must be a challenge, and it has different levels of difficulty, because if not, you automatize your process and you don't increase.
I have a question for both of you, but before that, one comment on not only learning difficulties, but how efficient all our brains should be. So in the case, for example, many kids who struggle with math, and the solution typically is, hey, let's give them more math, right? And more math and more math, and hopefully they will get it. Versus, for many of them, the bottleneck is working memory. If you don't have enough working memory to process symbols and to manipulate them and to do what you're supposed to do, you are going to struggle with math. So perhaps in the future, we'll see more targeted interventions where maybe 10 hours or 15 hours of training, working memory, will help you translate into much more efficient math through the whole year. And we're talking then 15 hours, which in a given year is nothing, but still we don't see that being implemented in the way it should. So that was the comment. But the question for both of you, given you sent me the papers of what you did in SEC, it was with students in first grade and in third grade. So the question for you, now that you're going to do that research on how it translates into academic achievement, what's your hypothesis? In which of those two groups do you think you are more likely to see the academic benefits because maybe they need it, and maybe it's more age appropriate that they use those exercises in that age group?
I think that academic improvement must be higher in children with learning difficulties. I don't know.
Comparing all the kids in
all
first
the kids,
grade, first or
but
third
our
grade.
students with learning difficulties are for different degrees. They all have the dyslexia diagnosis, and it's very interesting that the task is not using letters and verbal language. It's number, relations, spatial, and they have improved not only in their cognitive processes, but the teachers have told us they have improved also in their dyslexia problems because it's a spatial orientation. And the children without learning disabilities, they are all from third degree, 8-9 years. I think that maybe we can't compare because the different ages, because we have this year children of 11 and 12 years with learning disabilities and with 8-9 years. I don't know, but I think that maybe the improvement could be high in both groups, but higher in those children with learning disabilities. I don't know.
And I think, I think you'll see the academic, because in grade 1, a student hasn't fallen very far behind. And certainly in our work, we see, by grade 3 or 4, they're often can be 1 or 2 or 3 years behind. And that's where you see more of a catch-up because there's more of an academic leg. And certainly in the research we've done, we've looked at imaging, so we've looked at the changes in the brain. We've looked at cognitive changes, so we see working memory, we see long-term retrieval, short-term retrieval, fluid reasoning, processing speed, cognitive efficiency, all of those measures shift, this visual, spatial, executive functioning in the research, and we see academic outcomes related to that, and we see social emotional well-being measures, like Carol Dweck's work, growth mindset. We find these students develop an incremental theory of mind because you can't be in a program that's driving neuroplastic change in the brain and feeling that your intelligence is fixed. It makes no sense. And we saw reduction in cortisol, like the kids got to spit twice in the study, which would be kind of fun to do. They loved it. And we saw a trend where cortisol was reduced, and it makes sense. If you live with a learning disability, as I did, you are stressed every single day of your life because you walk into that classroom and it's not a fun environment, right? Like for me, my school was right across, the street from where I lived, and I could look out my living room window and see the school. And every time I walked out that door, I was terrified. Like I knew whatever waited for me on the other side of the street was not going to be a fun experience. So it makes sense that cortisol reduces because it's a stress hormone. There was a study done in Canada, a really very good study, looking at correlates of having learning difficulties. I mean, they looked at mental health, 3 times the rate of depression, anxiety disorders. They also found a higher incidence in adults with learning difficulties and physical, like autoimmune disorders, which kind of makes sense to me. And I developed an autoimmune disorder because if you're living with all that stress, you know, you think about all those stress hormones and the impact they have on your endocrine system and your immune system. So a learning difficulty is not just about learning. Like it affects your relationships with other people as well. Like it's like, to me, this is why I'm passionate about putting this work out into schools around the world, to make it accessible so these students, you know, don't have to have that struggle. I attempted suicide at age 13 because I just couldn't imagine. Like I'd finished elementary school, right? I finished grade 8, and I thought, I can't go to high school. Like I could barely cope in elementary school. You know, how could I handle high school with, you know, different subjects, different teachers, finding my locker? I had a spatial difficulty, so I could barely find my way out of the house. You know, and I can laugh about it now, but it was that kind of despair, you know. So this work can benefit all aspects of learning, but my heart and passion is with those students that are struggling, right, that are going to be marginalized in some way if they don't get the cognitive ability, you know, to make a difference. You know, every child should have, you know, access to a positive learning experience, and a lot of students with learning difficulties don't.
Okay.
All right. Before he commented about the difference between first grade and third grade, and you said that, well, fourth graders, they would be a few more years behind with learning disabilities, whereas first graders would barely be starting to be behind. So which one would you consider to be a better improvement, giving those first graders the tools and like the requirements to show them how to be in the same level to not be left behind, or would it be better later on once?
The first one. I mean, my belief is it's just, if you're doing research, you're doing it to show effects of something, right? But for me, you know, this work should start in grade 1, and we're just working with a school in Wellington in New Zealand where, you know, I have this vision in each grade, starting in grade 1, we do a developmentally appropriate cognitive exercise for what's going on in the brain at that point. So I have a whole plan, right? So they're going to start it in February. So grade 1, we're doing motor planning, which is a specific area that, you know, you're learning how to write in grade 1. Grade 2, we do quantification sense. It's I believe, the horizontal interparietal sulcus. Then grade 3, I have to remember, grade 2 we're doing visual memory for symbol patterns. Grade 3, we're doing the quantification sense. Grade 4, the symbol relations, the clocks exercise. Grade 4, starting to bring executive functioning, the prefrontal cortex. Grade 6, the prefrontal cortex, but the nonverbal piece. So every child is 30 minutes a day, 5 days a week. What we trialed here, we'll be doing a different cognitive exercise. So it just normalizes it, because there's tremendous stigma still to having a learning difficulty. And here, every child is going to school, and part of their day is working their brain. And then the students that have maybe more cognitive pieces, we'd have a cognitive classroom running all day that they can go in for a couple of more periods. But the earlier this is addressed, you know, when we start in grade 1, a lot of these students never recognize that they have learning difficulties. By grade 3, a lot of students, you know, recognize that there's, you know, something different. I mean, I knew in grade 1 because I had such severe learning difficulties.
So I don't know in Spain how you call educación física, like physical education. So the same concept maybe will arrive to educación mental, no? So it will be like a set of structures of cognitive and probably also emotional, like self-regulation of stress. For everyone to learn that, as we learn history or math or reading, whatever, we will have a curriculum that is for everyone, so there's no stigma, and it prepares everyone to cope with the demands now and in the future. So what you are developing and what Seki is experimenting makes a lot of sense. And and also interestingly, your school is IB-based, so the IB methodology is very similar. It's not so much about content transfer, which is the development of quite deep, profound capabilities. So the frameworks, I think, are going to meet and be very, very synergistic.
Great, thank you.
Well, I've noticed that you've mentioned a couple of times through the talk that um, education centers and schools are sometimes even a threatening center for students with learning disabilities to learn because it generates a lot of stress. The children cannot bear to not be able to learn like the rest of their partners and fall behind. And I was wondering if you believe that the current education system is obsolete, that we should evolve into a new kind of education system that generates some kind of equality and introduce this kind of help, because you have also worked with children without these disabilities, if it would be able to make universal this kind of help, and also how would you implement it? Because I have someone close to me that goes to these support programs because he has some kind of learning disability, and he feels really alienated when he goes outside his classroom to go to another program. Like, my partners don't have to do this. I feel really weird. I feel alone. So how would you implement those kinds of programs?
Yeah. Well, I think as we're doing here, or that school in New Zealand, it's just a normal part of curriculum. I mean, that's my vision. You go to school to learn, you learn with your brain. Let's put the brain into the equation of education. So school just becomes a place that you go to, to learn content. You learn, you have to kind of learn some material, but at the same time, it's just normal that you're working your brain. So they're cognitive exercises, and as Alvaro said, I think the other piece is, to create, moral and ethical human beings. I mean, the Dalai Lama has a whole big initiative, right? How do we create moral and ethical human beings? And to me, cognition is a piece of it. Like, that how do we learn? We learn with our brain. I mean, if you think about empathy, it's if you can't take the perspective of somebody else, you cannot be empathetic. And in some cases, that might be coming out of an emotional place. But I work with students that have problems in the right prefrontal cortex, and they can't relate to people. Like, they can't recognize if you're upset. Like, they can't read that, so they can't develop empathy because they can't read or experience emotion. If it's cognitive, we have work that can be done to stimulate that part of the brain, so then the person can have empathy or put themselves into other people's perspectives. So I think education needs to change. It's really not about content. I mean, right now you can go on Google, right, and you can find pretty much most information, but you need to be a critical thinker. You need to have good judgment. You need to reason. You need, as I said, have empathy. And school should be a place where all of that is part of the curriculum. And, the brain needs to be part of that, because our brain filters our perceptions. Like, it filters our understanding of ourselves, of other people, of our world, and our relationship to that. So it's a fundamental part of how do we become full human beings, right? So I just think we have to reconceptualize, how we see education. It's not about just learning content.
I would only add that I think that's very true, and I agree. But I would say not only for the example you mentioned, but for every one of us. In a sense, each of us have specific learning needs, strengths and weaknesses, and the more we can do for everyone to adapt and to improve, that's going to be important. I think schools still are going to be around for a while. I mean, frankly, public schools is one of the amazing inventions of humanity. They have only been around for a few hundred years, which is amazing. Everyone has access to that. It will evolve. I think it will personalize. It will be maybe classroom with technology, maybe better assessments, pinpoint your specific needs, so then you can perform better in the classroom. So I think what you are doing, and this year with COVID, ironically, has been a benefit to reconsider what is education and to combine the classroom and to combine technologies. So I think, ironically, maybe it has helped us advance in just 2 years, 50 years. Yeah. So hopefully we will find new models. And my only comment would be that I think education is not only out of schools. Education is a lifelong process that each of us have to feel responsible for, our ownership, as parents, as individuals and citizens. So don't think teachers are the only ones who teach, and schools is the only place where we learn. Learning happens every single day, happens everywhere, and I think we have to raise the awareness of people to realize we have long lives. Yeah. We have to develop that muscle of learning, and that's a joyful process when you do it well, And hopefully schools can spark that passion and that interest.
Thank you.
Mi pregunta es sobre el programa, porque yo el año pasado pues estuve trabajando con él gracias a Gloria y quería saber que, porque hay muchos niños que están... mi pregunta es sobre el programa, ya que estuve trabajando el año con él, con Gloria, y mi pregunta, hay muchos niños que están muy motivados a hacerlo, pero luego te encuentras a otros que se atascan y no quieren seguir. No sé si tenéis pensado cambiar algo para esos tipos de niños que se puedan atascar. A lo mejor puedes poner los diferentes modelos, por el Equal Length, por ejemplo, con azul y el Missing Hands en rojo, así, colores así. O algún cambio más dinámico para que no se pierdan y no se atasquen.
So around motivation, I think you're asking. Like it is hard work, right? I mean, to do this work, I think maybe you mentioned, but Laura mentioned it. This concept of effort for processing, right? To drive neuroplastic change, it isn't easy, right? To drive, like, we hear that every time we do anything, like every time we do anything, our brain changes, which is true, but a lot of those changes are really meaningless, right? They're transitory. So to drive the kind of change that we're talking about here, it takes that concept of effort for processing. It is work to do this. And a number of students, if they've experienced learning difficulties, often they've just given up, right? Because they've learned that effort doesn't lead to success. Like I can do 5 minutes or 25 minutes, I get the same results. So why am I going to do the 25 minutes? And part of the job here, which is separate from the cognitive exercises, but it's to get the student re-engaged, right? That like maybe they only start with 2 minutes, but that gets rewarded. Then we build up to 3 minutes. So just good motivational techniques, right? Or 4 minutes, or whatever it is that's motivating for that student. So all the things that, we learn as teachers around motivation, like, and then as they start to master, because we've built mastery criteria into the program, right? Because, Maslow's work, and we all want to master things as human beings. So once they start to master, that's motivating. But we have to get them to that point of mastery, right? Which doesn't happen right away. So any kind of external rewards that will get them there, we can use anything. Sometimes it's group rewards, if the students meet certain criteria, then the whole class gets, some kind of reward. So it's just using really, really good motivational techniques. The reasons why we haven't built gamification into the actual cognitive exercise is because it's going to detract from the stimulation. Like we're trying to do targeted differential stimulation, like target it right into that cognitive function without distracting into other cognitive functions. So there's reasons why we don't use color, right? Because that will, start to call in other cognitive functions there. But one of the things that we've explored and we haven't done, like if you have a Fitbit and you can join people all around the world, and tracking your progress, like things like that don't take away from the cognitive exercise, but are good motivational techniques. So it's a really good point. And I mean, some students, are incredibly motivated right away, and others you have to kind of build that muscle with them. So whatever is positive, and we've built a whole motivational toolkit, right, that we have, right, to support students with that.
Yeah. But speaking of gamification, not talking about Arrowsmith, but this company is trying to do that for other problems. And for example, in the US, the FDA, which is the agency that regulates medicaments, last year approved a video game designed specifically to improve attention among kids with attention deficit disorder. So it doesn't treat the whole disorder, but clearly it's been designed to engage the kids and to train them in a way that helps them alleviate a lot of symptoms. And yes, the quick question is how to deliver the right exercise, but in a way that is not a magic pill, right, that you take and it's done. You have to do the effort, so you have to find a way to engage.
Yeah, I think that some children have a problem when they start, and it's that they have low frustration tolerance, and then they need help. They request for help all the time, but because maybe they feel that they can do it, I can try it because I will do bad.
Yeah.
And then I prefer not to do it. And it's the teacher in this case who is working, motivating, but then if it's so easy when you start, it is not a challenge. And maybe it's not too very good for your brain for improve your cognitive process because it's too easy for you and you can do it by an automatic way. And it's the work for the teachers to try, and then the children feel that, oh, I can do it again. And in the program, the teachers have also the possibility to adapt to some children the challenges that they have to gain.
Quería solo puntualizar, yo como Sara, en español, pero entiendo bastante bien, solamente quería puntualizar que los casos que son más difíciles son aquellos niños que previamente tienen una baja tolerancia a la frustración y poca persistencia en el trabajo. Esos son los niños que más cuesta motivarles. Entonces, lo que decía Laura, que al poder manejar también el nivel por parte del profesor, sí que lo adaptamos, se puede ir adaptando a su nivel de tolerancia a la frustración. Entonces, eso es lo que veo yo que es muy positivo para un poco adaptar también el programa al nivel de tolerancia a la frustración del niño.
Yes, I mean there should be that flexibility, right? That you know, because we have to start with where the student is, right? And some students need something to be simpler, right? Or maybe, you know, fewer trials at the beginning. Like they need to experience success to then build on that. So as much as possible, yes, I mean we support individualizing it to get them into then being able to engage in the way that is required. I mean, I remember one student that, you know, because, you know, the program, it tracks how many minutes the student actually has been engaged. And the student said, I only worked 4 minutes, right? But I sat here for the whole 25 minutes. And in that student's mind, sitting in a seat and occupying space was working, right? Because that was their experience. So it's starting where that student is. So if it's 4 minutes, then can we get them to 4.5 minutes? Or, you know, and then eventually that individual could engage. But we always have to start with where the individual starts, right? So I think, yes, to your point.
On a similar point, but different, right now in China, you know, there's 1.5 billion Chinese, they have millions of children. They're experimenting with technology where kids have a headband that simply measures the level of alertness. And it says green, I'm alert, red, I'm not. And then the teacher can see so it can be scary, right? You think, wow, I cannot get distracted or daydreaming without my teacher realizing. But I mean, it's interesting to realize, hey, if I'm teaching, I'm boring, and everyone is in red, maybe I have to make it more engaging.
Yeah.
Maybe we can try it here.
Yeah.
How do you see education in a short-term future due to the pandemic, and how do you think this pandemic has affected negatively or positively children with learning disabilities?
I think I'll start with the latter. I mean, I think traditional programs for students with learning difficulties, they've significantly been impacted because a lot of times they need extra support, and that's really challenging if you're a teacher trying to work with 20 students online that aren't, you know, you're not physically present with. So certainly all of the research is suggesting traditional programs for students with learning difficulties haven't been affected. For the work we're doing, because it's not traditional and it's cognitive, for 2 years now we've been doing research and tracking the results we're getting on assessments, but also rate of progress through the work, we're seeing no difference between when we did it in person, and this is around the world because we're in schools around the world, and online. But to me, it makes sense because it's a different program. Like it's very much it's calibrated to that individual, to the movement of that individual through the work. So.
But that's surprising. So how do you address the motivation issue when people are at home?
Well, we have teachers, like they're in a virtual classroom. So there is a teacher in a Teams classroom or a Zoom classroom, but you can track all the progress. We track down to keystrokes, right? So we know if a student is not engaged, the teacher knows with the student. And then again, working with motivation techniques to support that student. But we're seeing no differences, which, is really encouraging because I was a little worried because within March 2020, when schools around the world shut down, in 3 weeks we were online, around the world because we had to deliver this program. So, I think there's a difference because of just the nature of the work. And I think Álvaro, what you said is one of the positive benefits from COVID is it's made us question our presuppositions, like in our assumptions in education, right? Is looking at, are there different ways that we can educate? Are there different things that we can do? Because it interrupted. COVID was probably one of the biggest disruptors to education certainly that we've seen in our lifetime, right? So it made a lot of people think about other possibilities. And my hope is we don't go back to, the way we were doing things before, and maybe we won't because the disruption has been long enough.
I agree.
You can probably speak to that.
No, I agree.
Yeah. Have you tried the program on children with mental disabilities?
Sorry, how?
No entendí la pregunta.
Just didn't hear.
Pero con discapacidad, with mental disease, with lowest cognitive ability.
So what we've found, this work was developed for me, so individuals with what we call, in the Southern Hemisphere, they call it learning difficulty, which I prefer than learning disability. In the Northern Hemisphere, we use disability, so I'm trying to change my language. But so students with learning difficulties, by definition, it means you're working within a baseline of overall average intelligence, right? There can be a huge range within that. And then with unevenness in the profile, right? So there are things that, people can do well and other things that they really, really struggle with. If you're looking at, individuals where, I can't remember, the intellectual disability, the terms change all the time. What the research is suggesting in those cases is there's less neuroplasticity because pretty much the whole system is functioning at, level of difficulty, right? Like it's not, where you're dealing with someone with a learning difficulty, there's unevenness, but there are things that are within that average range, whereas with the intellectual disability, everything is much, much lower. And certainly a number of years ago, in my work, I did an experiment with a number of individuals that would be in that range. And we're talking about, intelligence under the 5th percentile across the board, so that's pretty low. And what we found was the rate of progress was so minimal, right? It didn't make sense to continue. The parents were happy because their children were in a safe environment, but we weren't really seeing significant cognitive changes. But where there's the unevenness, like I've seen some students where things are at the 5th percentile, things are at the 25th percentile, and there we've seen, there has to be kind of that range or discrepancy. For this work, I believe, to be of benefit. And maybe down the road we'll learn other things and it can be different, but certainly that seems to be what the research is saying, and that's what the practical experience, and I don't know.
You have something in your hair.
Oh, I have something? A bug?
Yeah.
Oh.
I think I got it out.
You got it? That was good.
Yeah.
This is like when I garden, I have twigs sticking out of my hair.
All the way from Canada.
Yeah, that's right.
Yeah. No, but speaking of neuroplasticity, a different topic we haven't discussed yet is language acquisition. And it's pretty funny. Now we're in Spain and we're speaking English. And so this is amazing, the ability to speak multiple languages. And it's great precisely for the prefrontal cortex.
Yes.
It's an example where right now I have to realize, well, I was speaking English, a word is coming to my brain in Spanish, I have to suppress that and then bring it in English. So I'm fortifying just that practice constantly. Yeah. And in fact, speaking multiple languages and practicing that is one of the things that can delay the onset of dementia because of that lifelong cognitive exercise.
Yes.
Really specific to what you just said right now. What about somebody who's bilingual, like grown up completely bilingual? Would that be different? Because I don't feel like they would be suppressing certain words anymore. They'd just be knowing how to just say it.
Well, it's true. It would be less, but still, I mean, it depends on what you are learning, right? For example, I learned all these topics about the brain and neuroplasticity in English. So I can be bilingual in many things, but if I speak some words in Spanish and I read some books in Spanish, it's a challenge for me to realize how to translate into. So close to no one is perfectly bilingual on all the topics. So you are always going to find things to do. But the key thing is practice. And this is one thing that typically people don't explain. So people say, well, I want my kids to learn Chinese because that's super difficult and that's the best for the brain and neuroplasticity. Well, only if the kids learn Chinese and will practice Chinese for decades, because the benefit is in the practice, not so much in the learning itself.
For sure. All right. Thank you.
Yeah, I'm a musician and I can change the musical language and Spanish. English not as well, but Spanish and musical language it's so similar because I can read notes or letters without thinking in changing because practice. Okay, the last one. Because we have to go.
First of all, thank you so much for taking your time.
Because we don't have no more answers. So
no more neuroplasticity.
So you've mentioned that different children with different learning disabilities have shown different results. So my question is pretty simple. Have you seen learning disabilities that have shown better results or better results than others?
It's a really, really good question. I can't answer it 100%. I mean, because we need bigger samples. We're doing ongoing research constantly. I'm doing research here. We're doing research with a researcher in the States and in Canada, and we're just constantly building up our data pool. But there's certain cognitive functions that move more quickly than others. Like there's some of the receptive areas, like the symbol relations, the clocks, seems to, and maybe because of the nature of that cognitive function, move more quickly. The motor planning is the slowest one to improve, and I believe it's because we have to work through the motor system, the muscles, and the muscles tire before the brain tires, right? So it just limits the stimulation. So based on the nature of the cognitive function, some moves more quickly than others. And then there's different severities. I mean, we see students with mild, moderate, or severe difficulties within specific cognitive functions. So currently in the work that I do, we can identify 19 different cognitive functions and put them on a scale from above average to mild, moderate, or severe, or sometimes people are coming from outside of the solar system. Like there's some cases where it's almost at the level of what you consider with a stroke. So it depends on the degree of severity, and it's on different cognitive functions, right? And the nature of the cognitive function. So everybody has their own unique profile, and so it's not simple. Like when we're looking at an individual, they're complex, right?
Your friend has come back.
Oh gosh, this is. I'll bring him back to Canada.
Back to
whatever.
Canada. Yeah.
All right. So it's really complex. So to really be able to answer that question, we have to have a huge sample size, and that's what I'm hoping over time we can build up. And then I believe there's variability in plasticity, right? I saw two 16-year-old young men a number of years ago and had very similar profiles, similar backgrounds. Like there was nothing that was distinguishing between the two of them. They did exactly the same amount of work, and they both made progress, but one went 4 times faster. So that same amount of effort. So probably he had, more of the genetic markers for neuroplasticity. And interestingly, a number of years ago, I got very, very sick and almost died, part of my autoimmune problem. And they did all sorts of genetic testing because they were trying to figure out what's wrong with me. And probably there were lots of things wrong with me, but in that, they found I have one of the markers for accelerated neuroplasticity. And it just to me was really interesting. I created a program based on neuroplasticity. Unbeknownst to me, I have one of those genetic markers. So there's so much that we don't understand yet. And that's to me, if you're in this field of neuroscience, like it is to me one of the next frontiers. And it's really, really exciting, right? So maybe you will answer that question in your work and build that bridge between education and neuroscience, right? There's just so much to do here.
Two quick comments. One is not, there's many things that influence neuroplasticity. In your case, can be the genetic market, but it can be physical exercise. People who are physically active, that helps, or people who regulate stress, because stress can inhibit. So it is a number of lifestyle that can enhance that, and maybe that makes those students more likely to benefit. Yeah. But another question, very interesting to observe the question and the answer. So the question was about specific labels. Like typically we categorize people in this problem or this problem, this problem. The answer was about functions.
Yes.
And that transition needs to happen in learning and in mental health. Yeah. Typically there's all these labels that typically are not very scientific or very objective. It's just a consensus. We call these people X for whatever reason, but that's going to change because the science and the interventions are about functions. Yeah. So there's going to be an interesting exercise that I encourage you to lead, but it's like, well, how in this diagnosis, what are the key functions? Yeah. And then in some of them, for example, back to your question, ADHD is one area where we've seen in the US a lot of interventions targeting and helping kids with attention deficit disorder. Could be targeting working memory, could be targeting something else, and that seems to transfer well to their symptoms and to academic. So there's a number of problems, but the key trend here is to think more functions and less labels.
Yeah, we don't use labels at all in my work, right? Because we say you have to go under the label to understand the functions, because that's what you're working with. It's not the labels.
And that is the challenge. And if some of you here in neuropsychology, that's going to be very interesting, because if everyone is obsessed with the labels, and it's like binary, you have it or you don't have it, it prevents people from understanding the real problem and the solution. So neuropsychology in the future hopefully will be more about solutions and less about perfect tests and results that don't lead to solutions.
Yeah, there was a study of people interested, I think it's in Current Biology, February 2020, which from Cambridge, and was looking at that, and they were doing imaging, and they were trying to tie diagnostic labels to imaging, found there was no correlation whatsoever, right? So to your point, it's just an artifact that we've created. We like to categorize and put people in buckets, but those buckets do a disservice to the individuals.
And in the case of mental health, for example, anxiety is underlying many, many mental health problems. So instead of thinking all these 10 different categories, let's help everyone better cope with stress and anxiety, because that's going to translate into many good outcomes. So there's a change in mindset now, and people in the US are working hard trying to think how do we change there is called the DSM handbook of mental health, because again, it's pretty surreal what's going on. So hopefully there's many opportunities to improve.
Yeah.
Okay, thank you so much. Miguel Angel, please. I would like that Miguel Angel is the other person who works with me in the Arrowsmith program, please.
Really, thank you very much. It's a great talk about this question about the neuroplasticity, and also about the transdiagnostic perspective in the mental health. I think is the future, sure. And now is the moment to finish, because the Global Education Forum is starting and now. And thank you very much, a very warm, and for the next time, maybe tomorrow.
No, it's here.
Thank you very much for coming and for participating in this conversation, because it was not a talk, it was a conversation, I think. And thank you very much, Barbara and Álvaro, for all. I think our students have learned and enjoyed this talk.
Yeah.
Thank you very much.
Thank you.
Thank you. Thank you. Thank you.